So, first of all, my name is Dorota Jarecka. I work currently at MIT in Satterjit Ghosh group, and I'm a member of the Reproducible team. And first of all, I want to really thanks all organizers to organize this in Europe, because it is indeed our first European session. And as you can say, I'm European, so I'm always happy to teach in Europe. So, okay, so let's start from asking question, what is actually version control system? What do they do for you? So, first of all, they track changes in your files. So all the files, either is it like script, source files, configuration files, data. You can always figure out what are the changes from yesterday, from 2 weeks ago, from 2 years ago. Yeah. The other thing is that they keep all the version of the files. So you are not only able to figure out what is the difference, but you can easily access the version that was 2 weeks ago, 2 days ago, or 2 years ago. Yeah. And as you can tell from our previous presentation, this is actually you can see right away that this is very crucial for reproducibility. That's why we tend to teach version control system as a basic things for reproducibility in science, because this is exactly what we need. Yeah. If you are not able to come back to the version of code that you are using when you publish your results, you are not really able to reproduce your data. Yeah. You can say that you are using something, but if you are not able to really provide the source code, provide the data, we cannot really talk about the reproducibility or even replication of the results. Yeah. And in a way, I know that many people were thinking about this already, and you can say, I got this already. Yeah. And this is many people approach to doing exactly this, so that you can always access the data, your files from specific moment of time. Yeah. So this is basically famous PhD comics, and it's basically showing the everyone's favorite experimenting with suffixes. Yeah. This is probably the most well-known improvised version control. I wouldn't call it system, but it definitely it's well known for probably all of us. Yeah. So, couple of obvious issue with this approach is that even if some of the suffixes make sense for us today, you will probably not be able to tell in 2 months whether you use the usual version or use this one for your publication. And even more important, it's very hard to work with others and share this kind of approach with other members of your team. Yeah. So let's say that this our previous approach with suffixes might solve some of these problems, but they're definitely not perfect. So, and coming back to the version control system, that on top of tracking changes and keeping all the version of the files, it actually allows for easy collaboration and also really improve efficiency. I know that many people would say that at the beginning, it's one more thing to learn, one more thing to think about, but it's actually once you start using this, it became pretty quickly became obvious that it does improve your efficiency. Okay, so talking more about the concept. So basically, the main concept of having version control system is that creates a snapshot for you. So basically, this is very, very conceptually, it's very close what you often do, experimenting with the suffixes. Yeah. So you copy your so you often create a copy of your working directory, but and create like something like this snapshot. Yeah. So basically, snapshot is the version of your entire directory at a specific moment of time. Yeah. In addition to this, like instead of like creating this all like suffixes, what you might figure out at some point that it's nice to include some metadata. Yeah. And maybe it's not only like the like 2 letters suffix, but maybe it would be nice also to include more information. So in addition, version control system, in addition to create a snapshot, it also always like saves some metadata about the specific snapshot. And if you are moving in time, like you can see that, like, you know, once you are changing your working directory, at some point you might want to create additional snapshot and also provide some additional metadata. So this is like basically like, you know, we were talking about like the concept of version control system, yeah? And now we will be talking about like very specific tool that you probably like read about, and hopefully every single one of you has already installed on your laptop, that is called Git. So what is Git? This is probably like, like right now, this is the most popular version control system. It's free and open source, and it's distributed system. So you know, I will not talk about like all the details, but the very important issue, thing is here just to remember that it doesn't need the central server. So it's basically like every single person who is using this, like a Git, has copy of the entire repository and is able to work offline. That it might be like it's very like nice feature of Git. Basically, it can handle everything from small projects to large projects, and it's high performance. One of the things why it's high performance is that, you know, you remember, like if you wanna like create snapshot of your directory in like the very like ad hoc way, like you often like create a copy of entire directory every single time you want to create a snapshot. Yes. So, and basically you usually like multiple the amount of data you are saving on your laptop by basically amount of like time you are creating snapshot. What Git does is actually like it doesn't save all the data every single time when you create snapshot. It's actually like it's smart enough to be able to figure out what is the difference between previous version and the current version. So it's able to efficiently save like the difference between these versions. And one of the things that like many people are like you know laughing about, like it's like if you check the manual page of Git, it just says like stupid content tracker, yeah. And I think it's like, you know, it's kind of like very important to think about it in a way that, you know, Git doesn't make any assumption. Git doesn't know what you want to do. You have to tell what you want to do with your project, and this will be something that I will remind you during this class, because that's will be very useful for our hands-on. So this session is meant to be hands-on session. So I will be jumping between presentation and my terminal just to practice with you how to use Git. So first of all, I think I forgot to say at the very beginning, you know, I'm not really able to see your faces when I'm providing this presentation, and we'll be jumping between terminals. So please, if you have any question, please just, you know, unmute yourself and just interrupt me whenever something is not clear. And the other thing, like right now, I really would like you to follow me along with this presentation. I will try to be pretty slow. I'm a slow typer, so you should be able to follow me. But right now, I think the most important thing is that, you know, we probably all are using different operating system. But if you can go right now and open terminal, that would be great. So I can give you like a couple of seconds to do it. And what might be useful for you, just to, open the terminal next to the presentation. So next to Zoom. So you would be able to see what I'm typing. So you would be able to repeat. If you are not able to, again, I will try to be pretty slow. Even if I don't try, I will be pretty slow. But also you will have this presentation on the website that Per provided you at the very beginning, and you can just copy the comments from the PDF, right? Directly from the PDF of the presentation. So hopefully everyone is able to find terminal, and I think Per asked you to install Git, and that obviously we have only 45 minutes, so I will not be able to fix the installation issue. But let's try if everyone has Git, and the easiest way way of doing this is, for example, just using basic shell command that is checking the help of Git. Yeah, so you can type git --help, and you will see. I see that someone is chatting. Oh, okay.
Yeah, I'm monitoring the chat, Rhoda.
Okay, thank you. Yeah, so please either interrupt me and ask question directly. If you don't want to do it, you can also type question in chat, and Fer and others will be able to answer. So hopefully you have at least some basic knowledge of Git of shell commands. If not, I will try to also explain you the command that I'm typing along. So first command that we are that's a very easy way of checking if you have Git installed. Hopefully everyone can see some basic help for Git. As always, you have when you type GitHub, when you type help, you have options for sub commands to Git. You will see git clone, git init, etc. And we'll be practicing some of them. So hopefully everyone is able to see this. The next part will be only for first-time users. So it's very nice. It's a very good idea to configure your local Git account. So if you've never used Git on your laptop, I would really recommend that you configure at least basic things like your username and your email. I usually recommend doing this with the flag global, that you don't have to do it in every single repository. Yeah, so I don't have to do it because I have already this. And you can always check by typing git config list to see if you already have the username and email. So I can type git config list, and I guess you can see that there are some basic things that I included already. Yeah. If not, you can always type git config /global user name and your name. And second, you would be git config --global user, sorry, that was typo, user email and your email. And again, once you do it, you should be able to see this basic information when you type git config --list. Okay, so hopefully everyone who's trying to follow this was able to set this basic configuration. And once we have this, we will talk about remember that the basic object for every version control system, it's files, yeah? So it's the smallest kind of, smallest object that we are able to add, like to use in your work with version control system, yeah? So it's very important when you work with Git to understand the life of files in Git repository. So there's like a very nice image from one of the books, and the book I also like included the link in the workshop website, so you can always go and to check this book. It's a very nice book that you can access online. So it's very important that this slide is actually contains a lot of information, but we will be practicing this today. So again, repeating that Git is just a stupid content tracker. What does it actually mean is that it doesn't make any guesses for you. So every single file in the directory that you are working on can be either untracked. So that basically means that Git doesn't know about this. But once you provide the file to the Git repository, it can be still in 3 different stages. It can be either unmodified, modified, or staged. And today, basically, we spend quite a lot of time just practicing exactly what does it mean and how to work with files in the Git repository. Oh, sorry. So let's start. Let's come back to our terminal and start our project. So let's say you want to start completing your work. So you can create a new folder, and ensure you can use mkdir to create a new folder, and you can type my project. You can change your current directory to go inside to my new project. And at the very beginning, if this is a new directory, it should be it shouldn't be anything inside. You can also check for any hidden files. You can also see it's pretty empty. So once we can create a few files. Let's say I will create, and again, you can open your text editor to create new file. I will try to use some shell commands. So in case you don't have any text editor ready, you can just follow me and just create files using the basic shell command. So you can type touch green text file. You can add some content to the file. You can use for this echo some content and provide this to the specific file you want. In this case, it's green. There's also very useful command that is called cut, so you can see what is inside our file, and you can confirm that it's we have simple content. We can create actually another file. Let's call it blue. You can actually do it right away with the echo. And you can see that you should have already 2 files inside your directory. So this is just a normal directory. We haven't done anything about Git yet. So the first thing, whenever you want to start your Git repository, you should type Git init. So that basically tells Git that you want to initialize the current directory as a Git repository, as a new Git repository. So you should type Git init. And you will have some basic information about, some feedback from Git. One of the things, and we'll talk about this later, that you actually can change the name of the default branch name. But we will be talking about the branch later, so I will come back to this later. So what you can see, so what happens, like, we didn't do too much right now, but when you check the content once again, you can see that still, like, your, at the first, when you just use the ls-l, you will see that the content is still the same. You still have like two files, one is blue, one is green. But if you actually type ls-la, so basically A gives you additionally the hidden files, you will see that Git already created like extra folder that is called like .git. You can even check I will not go into the details, but you can see that like Git already behind the scenes start like doing something in the directory. And basically that means that this is your new Git repository. I told you before that, sorry, I will come back to that were like multiple changes, multiple stages that for every single file that is in your Git repository. So right now we only initialize the Git repository, and right now every single file that we have, it's basically treated as an untracked. Remember, like Git doesn't do anything for you. So if you just initialize the Git repository in your new folder, but you still have to add every single file you want to track to the Git repository. So if you actually like check, there's like simple command that is called git status, and basically by checking this, you will see you will always like you can always check this this command to see what's going on in your Git repository. So right now you can see that gives you like multiple information. One is that you are on branch master, and again I will be talking about this in 20 minutes. The second, that there is no commits yet. I will also like talk about this like in 2 minutes. And there are two untracked files. So you see that basically like all the files are in this stage untracked. So in order to provide Git information that you wanna track the specific files, you have to use the command that is called git add and the name of the file. If you type git status again, you will see that actually you have like one file that is actually in your shell. It might look different. In my situation, it actually also changed the color, and it's telling me that I have like new file that I can commit the changes, and there is still one untracked files. So let's add the green files. And when I change the status again, you will see that like both of our files are green. So let's see what happened now. So basically, from now you see that like by adding the files to our repository, all of our files basically like jump to the point that were like in the stage. Yeah. So basically, like now it's basically like Git is telling us that we are ready to save changes in our repository that are included in the file. In order to save the changes in the files, we will use another Git command that is called git commit. So basically, like whenever you type git commit, you are telling Git that this is right now is the place where I wanna create my snapshot. Yeah. So this is the place that I did something meaningful, and I wanna save the changes. Like so, I'm always able to come back to this. So remember, I told you that in addition to saving snapshot, it always saves some metadata. One of this like important piece of this metadata is that it always wants you to provide some meaningful information. What happened? Yeah. So because this is like short tutorial, I will not be providing any like meaningful information, but I will just say that this is like my initial comment. Yeah. But this is actually like very important information of your Git repository, actually like your own information, your own message for future yourself or for other collaborators, what just happened, yeah? And now if I press git commit, you will see that Git will tell me that there are two files changed, and there are two new lines, yeah? So let's check our status again. Now you see that like it's telling us on bench master, again, I will talk about this later, there's nothing to commit and working tree is clean. So basically what we did was by having all like these two files ready to be commit and running the git commit, we actually like move both of these files to the unmodified stage. So basically right now we saved everything, nothing, and there are no new changes that we have to commit. Yeah. And one, like, I show you like git status. This is like a very useful command. The other very useful command is git log. So basically git log, remember like we said that like one of the most important thing that a version control system do it, like it just provide all the copies, yeah? And by typing git log, we can have information of every single snapshot we created. In this situation, there's only one snapshot I created. So there's only one entry, but you can see that you have like several information. So this like, remember like we created always snapshot and some metadata. So here you have access to metadata, yeah? First of all, you have like the ID of your commit. I will not talk about these details, but Git create a hash for you, and basically every single time you create new commit, you will have like very unique ID that you can always refer when you want to come back to the specific snapshot. You have information about author. That was like, remember I asked you to configure your Git because actually it's very important for when you are working with people that we know who made the changes, yeah? Additional information is like when these changes happen, and here is the Git message that I told you about, yeah? So this you can see that every single person later will be able to access this information, so it's very important that you provide some meaningful information. Coming back to our presentation, like, so we basically like move our untracked files to stage by adding them, just saying basically to Git that we wanna add these files as our files to the repository. We run git commit, so we move the files to unmodified, and now the next step, we didn't touch one more stage that is called modified, and as you can guess, like this is the stage that files are moved when we actually like modify this file. Yeah. So if I wanna add a new line to my, let's say, to my blue file, yeah, like another line. Now, like you can see that there is a difference. If I want to include the second line to the file, you have to use like double like a greater signs just to add new line instead of override this, yeah? So I will add this to the blue text. You can cut the blue. You will see that I have like another line. And you can check again our like favorite command, git status, to see, that like now our blue file is in like modified stage, yeah? So we basically, by editing the file, we move the file from unmodified to modified. And this is exactly what git status would tell you, yeah? Another useful command, if you have the file that you modified, is like git diff. And that gives you exactly what you would think it does. it provides information about which file has been modified and what are the changes in the file. Of course, like if this is like simple text file, like in our case, it's easy to provide. If that would be like different file, like for example, like data or PDF or something else, we will not obviously have some so nicely provided div because it's not so easy to provide div. But for like all the text files, all the script files, like either it's Python or R, you can always see what is the difference. And it's like, you can review the difference before you are actually like saving changes. So in order to create like a new snapshot with the new changes, you basically have to move the modified file to stage file. So basically the stage part is like when you are saying that these are the changes that you are ready to commit. So you can do git add blue, and you can change the status again, and you can see that like changes to be committed. Yeah, so our file is on the stage, and now we can provide again like some meaningful information. Here like adding second line. So now when you see like git status, you will see that again there is nothing to commit because like everything was saved. And when you see the history, you will see like, like with every single commit, our history goes. So you see like that was the commit that we have been discussing we discussed before. And now the second commit is actually like the changes we just did. Yeah. So again, this was done by me. That was done like that is my US time. And basically the commit message that I just provide, git adding second line. One thing before we move to second part is like Git is very flexible. Git is very powerful tool. I'm like showing you the basic commands. If you open any like book, you will see like Git has like many more like commands that you will some of this command you probably will never use. Some of this command you will like learn as you work with it. One of the very like and it also has like very like many shortcuts. Yeah. So when we work like with like this last modification, we moved the file from unmodified to modified by adding extra line, and then I git add to add the file to the stage, and then we commit the changes. One very famous, like very well known shortcut is just like running these two commands together. So if I like add another line to the blue, instead of git add and git commit, we can just use git commit. Remember before I was doing just -m to provide the message. But now I can add actually git a. That basically it tells Git that I want to save changes in all of the modified files. One of the good things about this, and you see we have another commit message. This is much faster than adding every single file to the stage. But remember, like when you have multiple files, sometimes it's not very good that saving all the changes at once. Yeah, but this is something that you will see in many situations. Okay, so hopefully you were able to. Hopefully you were able to follow what we've been doing. But if not, I just want to like quickly review what just happened. Yeah. So you can always come back to this presentation later. But again, so we started like new. You had like your project, your folder with your files. So you can always go to this project, you can start the Git repository by typing git init. I provided you some basic commands to check the status. And again, you have like information about all the files that could be found in your folder. At the beginning, every single file is untracked, so it's not known for Git. And if you want to add the files to the repository, you always have to explicitly ask Git to start tracking the changes in the specific files. There's something that I didn't show you, but like, you can practice this later. Sometimes you want to have a file, you have file in the repository that you don't want to track, but you also, when you type git status, you don't want to see these files as something that is untracked, yeah, because like that's kind of might be messy. So you can add you can create a special git file that is called git ignore, when you can add all the files that you do not want to track on purpose, yeah. And when you add all the files, you will see that like all the files are in the stage part and we're ready to commit. Next, having this, we provided some, we saved first snapshot, and we learned how to provide information that we leave together with the snapshot. And after this, you were able to see that there's nothing to commit. All the files were moved to the unmodified stage. We also practice what does it mean when we edit the file. So you could see that once we added some additional files to our file, Git will tell you right away that something has changed in your file, and you will have to either keep editing the file, or you might want to decide that this is the time to create additional snapshot and provide additional commit message. We also practice git diff. We practice adding a file to the stage part and creating a new commit. One also important command is git log. So git log basically gives you entire history of the snapshot of your repository. So basically, we practice entire life cycle of files in Git, and once again, repeating that this is just a stupid content tracker. Basically, what it means is just Git doesn't think for you. Yeah, you have to explicitly say what you want to do with files. And at the beginning, many people, I think they found this kind of annoying, but this actually gives you really a lot of power to decide exactly what you wanna track with Git, and when do you wanna save changes. So it might be at the beginning, you might think that this is one more thing to remember, but at some point it will be very, you really most of the time you are using 4 Git commands, and at some point you will just get used to it. Okay, so quickly, I will also introduce something that working with branches, because I think this is very powerful feature that Git provides. So when you think the way how we had our very simple exercise was we kind of provide linear model of creating snapshot. Yeah, so I create the initial snapshot. I edited one file. Later I edited the second file. Yeah, and it was everything was easy and kind of linear with time. Yeah, it's a very simple model that you're just progressing slowly, one step after another, and you have nice history. But like, one thing that we probably like realize in our work that it doesn't work like this. Yeah. It's like our work is actually like looks like more like trees with this multiple branches. Yeah. We often don't want to work at one time, at one piece at a time. Yeah. Many of our changes are not something that can be done within like 5 minutes. Yeah. Sometimes we are working on the features that can take like a day or like a week to work on this. Yeah. So we often like actually our like history looks like, it's like much more messy and like might remind me more like a tree with many branches than like simple like linear history. Yeah. And because that's how our work look like, this is exactly what version control system like Git also support. Yeah. So so when you see this, like we see that like actually like when you think about your work as like this like tree with branches, you can see that like it's not very easy to say which is our latest kind of snapshot, yeah, which is the most important thing. So we have this like from when we're deciding to work in this like branch system, like it's kind of like we have to also deal with the concept that there are several like latest snapshot that we can think about. Yeah, what is actually like always like important that like from the conceptual level and like also practical level, that every single snapshot we create, we always can trace back. Yeah, so every single like we have this concept of parent and child, so every single snapshot can have two child, but every single snapshot also knows how to track the parent. And this is like would be like very, very important information, that we are always able to track the history, because we remember like that was one of the most important features that we want to have from version control system. You always can track the history. So just to show you like the kind of example, like like you often like when you starting new project, yeah, there's a stage when you like thinking, developing your code, yeah, and at some point you have something that is working, yeah, and like it's working but it's not perfect. So when you have a choice, yeah, you can either like keep working on the same like the same branch, the same file, but you at this point you are basically risking that something that is working you will be destroying. Yeah, maybe you want to work on features that will take like 2 weeks, but you don't want to like stop using something that is working only because you want to develop something new. So this is exactly the place where you would use branches, yeah, because you want to like create like a separate branch that you will be thinking about your changes. And it can take us again like from the week and month, yeah. And sometimes you like at the end you just you just want to forget about this, yeah. You know that it's not the way you go, and exactly that's why Git allows you to actually come back, because remember, every single time you are tracking the history and you are able to come back to any snapshot you want, yeah. So if you are in this place, you can always come back to this place and start something new. And at the same time, the main kind of branch, the master branch, often how we call, or the main branch, it's kind of clean, and we are always able to work with it, yeah. And as you can imagine, this kind of approach gives you an ability to work on multiple things at the same time, yeah. Even if you are like a single person, and imagine if you have like bigger team, like many people can create like different branches and to work on different features at the same time, and do not like interrupt with each other, yeah. So we will practice quickly because I know we don't have like too much time. We quickly like practice checking branch. So again, you can go to your terminal, and in our repository you can type, maybe I will, you can type git branch. And right now there is only one branch, and it's called master. Yeah, in your situation it might be called main, but there's usually like one default name that you are using in different projects. Yeah. you can always add another branch. So you can always add git branch feature A. And when you check the branches again by typing git branch, you will see that you are like, the master is still green. Basically, that means that you are still on your master branch, but you created a new branch. And you in order to jump between branches, you can use checkout. And now when you see, like, the star or green or whatever, on your shell might look differently, you will see that you have like something has changed, yeah? So I still have the same branches, but now I'm actually on the feature A branch. So what does it mean? So, we don't have too much time to practice this, but I would just want to show you. So this is like the command that I just typed. So if you didn't follow, you can always come back to this later. But basically, I just want to like conceptually show you what does it mean to work with different branches. So branch basically it's just a pointer that pointers to point you to specific commit, to specific snapshot of your working directory. In order to, like in additional this branch, we have the idea of head. So basically, you see here that it's green or star has like it's either on master or feature A. It shows you where like there's a special pointer that is called head, and this head might be like jumping between these branches. So whenever we are like using checkout, you are basically saying like now point me to the feature A branch or now point me to the feature master. That basically tells you on which branch you want to work on. And I know it's a lot, but I will try to explain like a bit more. So remember, like we have like particular snapshot and we have 2 pointers, yeah? We have like, at the beginning, I only had master branch. So I had like pointer that it was called master, and the head. Basically head means like this is like the current branch I'm working with right now, yeah? If we are creating a new snapshot, we are basically moving the pointer that is called master and the pointer that is called head, yeah? That's what we were doing when we were like editing this blue and green files, yeah? We still have the initial snapshot, but we created a new snapshot and we are currently working on this like new snapshot, yeah? And it was like, it can go like this. And, in our example, we can do it like linearly. But what I wanted to show you is like just the idea of branches. So basically, at any point in time, you can create a new branch. That basically means that you want to like start working on something new. So as I show you, when you type git branch feature A, you are creating this new pointer, yeah? So when you type git branch, you saw right away that Git knows about new branch, feature A, yeah? So, but you didn't create any new snapshots, yeah? The only thing you did, you were saying that now I have another pointer. So you had the same snapshot, but you were saying, okay, there's another pointer, feature A, that we're pointing to exactly the same copy of our repository. If you are like using the command git checkout, basically is meaning, okay, I don't want to work on master anymore. I want my head to point exactly the same place as feature A. So when I'm changing like files, I know that this is part of our branch, not the main master track. So if I jump to feature A and I create some changes, I'm still like my master, it's still pointing to the snapshot I did at some point, like previously, and this is not changing, yeah? What I'm doing is actually like, I'm just saying feature A pointer just to point to like new snapshot. And again, like when I'm editing this new branch, I create a commit, I created another snapshot, and my feature 8 provides like point to this snapshot. So what happens if I'm ready to finish this? Yeah, if I'm ready to like kind of like I'm happy with my changes, and I want to like come back to my main branch that is called master, and I want to like merge this together. So this is actually, I'm kind of using already the words that GitHub is also using, because this is exactly what will happen. We will be like merging our changes. So first of all, you want to come back to this like main branch that is called master in my situation. And you can always like run something that it's called like git merge. And basically by merging like feature A, you are merging all the changes you work on from feature A to the master. So you see like this concept, like, like creating this like multiple snapshot, that some of them are part of like master, some of them are part of like new branch, yeah? And once you are happy with this, you can always like come back to master and provide like merge nicely everything together. If we have time, I don't know, do we have 5 more minutes or not?
Yeah, you have like roughly 10 minutes.
Okay. So this is something, I think this is like actually like, I know that there's like a lot of information, but I think it would be very nice just to like spend at least like 5 minutes just to practice this, what I just said. So, okay, so we are in this, in our repository. Again, the file that we're working on is like blue and green, yeah? So we wanna work on feature A. Let's say feature A is just adding feature A to the blue file, yeah? So we will be adding, yeah, the blue file, the blue. You can type git diff. You will see that something happened to the blue file. You can check the status, and you will see that the blue file again is modified. And now I wanna like save this, yeah? So again, like remember like to create a snapshot, you use git commit. I will use this AM, so basically I change only one file, so I will be saving only one file, changes to one file, and my message will be adding new feature. And again, we can see that our log, yeah? So now our history is that it basically contains all the commit message from the master, yeah? So you see that like this 3 commits we saw previously, but we create additional commits just for our brand. And you can see this is like more, and now we have like more information what some additional things means. So you see like head now, this is exactly what I showed you, I explained, yeah? Now our head, the pointer, special pointed head is pointing to the feature A because we switch branches. And master is still in the same place, yeah? So this is exactly, so we are here, yeah? So master is still pointing here. So this is basically the situation, yeah? Our master is still on this last commit that we did. We did previously, but now we set like new feature and we moved our pointer head to this new branch. So what are the consequences? So basically what you see git branch, I have like this two branches, and I can always come back to master, yeah? So remember, like, so whenever I type checkout master, I'm moving my special head branch to master, yeah? So now if I type git branch, I will be here. So my head will be in this place. So when I type git log, you will see that I will only, maybe I will clear this. You will see that I will only have like 3 commit messages, yeah? And our head is on master. Basically, my master doesn't know anything about changes that I did to the blue file, yeah? So you can actually check the content of blue file, and you'll see that like there's only like, 3 lines, but there's nothing about feature A. Basically, because like, like that was done in different branch, yeah? But again, if I'm happy with what I did, I can always merge the changes. So, like you can see that like from this place, I can even start a new branch, yeah? I can start a branch. Yeah, so I can completely like work on as many new features as I want, like without like interfering with each other, yeah? And if I wanna merge the changes, the simplest thing is like git merge feature A. So now it's like telling me that it merged the branch. I can check the git log, and you will see that I'm like you see that like the last commit from new branch is already in the master, yeah. So the feature B is still on this place because we didn't do anything to this, but now like master and feature A points to the same place, yeah. These 2 branches has been merged, yeah. And this is exactly what we often want to do when we are working, yeah. I know it's like a lot of new words right now, but this is basically what we usually want to do, yeah. When we're happy with our changes, we want to bring to our like master branch, but we don't want to do it before we're actually happy with it. So this is actually like very powerful feature that Git provides you. And again, like it's powerful even if you are working on your own. It's even more powerful if you are working with another people, because you can really collaborate on other things like separately, I do not have time to talk about remotes. The only thing I wanted to say is like probably you've heard about GitHub. This is basically the website that provides you with public or private storage for your Git repository. Basically, it's not required, but it's the easiest way to share your code and collaborate, yeah? In addition, like it provides like third-party website to interact with your code, so you can test, publish, etc. Yeah, basic service free of charge. Where also like other things, other services that you want to use. GitHub is not the only one, but it's like very, like there's nothing magic about GitHub. You don't need GitHub to actually work on your Git repository, and again, like you don't have to have access all the time to GitHub to work on your repository. So if, for example, if you're using someone else's repository and kind of save your repository, I don't have time to do this right now on your laptop. And even if someone like, deletes a GitHub account and you don't have access from this, you still have like entire copy of the repository on your own laptop, so you are kind of independent. So you don't have to worry what would happen if someone, delete GitHub account or GitHub disappears. You still have entire repository on your local machine. I know that was like kind of